Greetings to you, wherever you are watching from around the world, and welcome to our Let's Chat Solar here at Microcare Solar. We are, of course, at the factory in Nelson Mandela Bay, and apologies for the slight delay in the start. I'm Gareth Burley, part of the team here at Microcare, and we're a local manufacturer of solar equipment. We've been doing that since 1990, and we started these online chats to answer some of your questions, and just to assist. This whole solar journey requires so much understanding. There's so many technical elements to it and aspects to it. We're seeing some confusion across the country, even between cities, between towns, between provinces. There seems to be some confusion about the technologies and what it all does. So we're going to be using this time to answer some of your questions and address some of those. And we thought today, well, in fact, last week, we touched base on some of the fundamentals. We looked at inverters. How do we size the inverter? We looked at batteries. Why do you need batteries? How big must the batteries be? Are there limitations? Is there a small size, a big size? We covered a little bit about that, and then we spoke about solar panels and the difference, and that each of those three would play, the role that they would play in your solar system. So go and have a look there. That was our session 2 that we had last week. Today, of course, we're changing gears a little bit. We're answering some of your questions, and we're doing it live from our. You can hear some noise in the background because this is a working factory and it's been quite a busy day, lots happening on the factory floor. Right, so today we're going to answer some of your questions. Just to verify as well, we are live, so if you want to ask questions, you can do so on the live chat feed. And so many of you have decided rather, after looking at it, drop us an email, and you can do that at sales@microcare.co.za. We've received lots of questions. I hope we've been able to answer all of them, and we're going to try and address some of them here in these live chats as well. Right, and then guests, when can we be a guest on the show? I know there's lots of other live chat kind of forums that take place around the country, around the world. So wherever you want to join from, we look forward to be able to do that in the coming weeks. But for now, we're just sort of laying a platform of our conversation on solar. Please do keep those requests coming. We certainly look forward to hearing from you. So just to remind you, we're in Port Elizabeth, down at the base of South Africa. We're right in the middle, Nelson Mandela Bay, if you like, or Gqeberha, as we are now known. And this is where we're based, right by the ocean, just behind me, down in beautiful South Africa. Okay, let's answer some of the questions for today. I've got 3 questions I'm going to tackle, and we'll see how we go with those. So Johan was the first question he sent in last week. He said he's got a 13-year-old inverter. Can he upgrade it for the current lithium-ion batteries rather? So this is a common question that we get. And 13-year-old inverters, that's quite common. Of course, Microcare has been going since 1990. So we've had inverters that have come in since the 1990s. I know they're from the 1990s because they're beige in color. And apparently, beige was a cool color back then. Not anymore, I'm not sure. And then we had blue inverters, and our current range is all in the stainless steel. So 13-year-old inverter, can we upgrade it? And the answer is, of course, yes. And this is common now. People have got inverters, and they've got sort of old lead-acid battery banks, 2 volt, 6 volt, 8 volt, 12 volt cells, you name it, a whole array of battery banks. And now they'd like to upgrade the inverter to be compatible with the current lithium-ion technology and whatever other technology comes along. I think this is such an important question. And this is what we have here at Microcare. We've got a full in-house repair and upgrade section. Every inverter that's ever been bought can come into Microcare and be repaired and upgraded. We'll give you a quote, and for a fraction of the price, 10% of the original price, something like that, you can have the unit repaired and upgraded into current standard. So it's quite incredible. You can have your 13-year-old inverter sent into Microcare. We will do a full upgrade and repair, make it lithium compatible, and then have it equal to our current standard, 2023, October 2023 inverters that go out the door. So absolutely. And what we do is we basically update the software. Technology has changed quite a bit. So because we manufacture, because we have the IP, because we write the software, we're able to update the software for you. And that happens on the motherboard and on the screen. Now, we prefer that it comes in here because like a car, any machine, a good service would be a good idea. So I'd like to change the fans. The fans have got bearings in. They've been going for 13 years. I definitely would like to change that. So our team would have a look and then assess and say what would be the advisable things to actually upgrade your inverter, and then also to upgrade the software for the current range of batteries. Your older lead-acid batteries, they float and boost, and the voltage range was very different to what it is now. And so we're able to reset those settings because we write the software. And because the inverter's got that transformer in it, that big muscle, the big shock absorber we spoke about last week, it's able to go for many, many, many years. So you have another 13 years, no problem. Send the inverter in, we'll give you a quote for the upgrade, but certainly there's no need to replace the inverter. And it goes the same with some of our other products as well. So that's your question, Johan. I'll move over to Craig now to talk about the Giza controller. This is one of our newer products. In fact, you can see this is one of our Giza controllers in the back of the screen here. So the question was, how many solar panels do I need for the Giza controller that we manufacture? And can I use more than one Giza on the Giza controller? All right, so firstly, panels. Now, this is quite important. I think for those of you learning about solar, you realize that all solar panels, they're not all the same, and all products are not the same. And so what we like to do very simply is that you need to have a little window. There's a window of voltage and a window of wattage in panels that must be met. So we like to say on the Giza controller, for the panel wattage, we need between 1 and 2 kilowatts of solar panels. So that could be made up of, let's just say, 2 500-watt panels connected in series. That makes 500 plus 500 makes 1,000. So that's the minimum we would want, 1,000 kilowatts. But you also got to fall within a voltage window, an open circuit voltage. So every solar panel has a voltage. Those 500-watt panels, let's say they've got an open circuit voltage of 50 volts. Now 50 plus 50 series will make 100 volts, and that's going to be a problem. Because we need at least 135 volts on a 3 and 4 kilowatt element. I don't want to get too technical about it, but the key thing is you've got to fall within those windows of voltage and wattage with your panels. So on our website, we've got some beautiful brochures, we've got lots of information on our Giza controller. So you can use any panels, but you need to make sure that you've got enough wattage and enough voltage. And it goes the same with our solar pump controllers, it goes the same with our normal inverters with their MPPTs, our mini grids. There's got to be a minimum and a maximum wattage, a minimum and a maximum voltage. So the answer to how many panels is, well, there's no one answer actually. It's about what panels have you got available to you, and can we get them connected in series to meet that minimum requirement and then not exceed the maximum requirement. And then what about, can I connect more than one Giza? Maybe I've got 2 Gizas in my house, can I use it for that? Well, that's not what it's designed for. It's designed to heat one element. So we take solar power, we use our clever Giza controller, and we connect it directly onto the Giza element. We just include a thermostat to read temperature because there's not much intelligence coming from that element in the thermostat. So we just simply add a little thermostat into that and to give us that temperature. But other than that, it's a 1 Giza application. So if you've got more than 1 Giza, you'll need a separate application. All right. So the current standard of Microcare Giza controllers is for 1 Giza. All right. So that's Giza controllers. Brilliant product. I've got some amazing data and information on our website and our Facebook page as well. It's Wi-Fi enabled, so you're able to measure the temperature there. You're able to set timers if you want AC fallback. Really good product. I heard from a client last week saying that so far this year he's only used Eskom 3 times, which is phenomenal. Okay, he's a single guy. He's got a Giza controller on there. He doesn't use much hot water in the daytime. So even in inclement weather, the controller is working really well. So that's a great product there. Go check it out, the Microcare Giza controller. You can use any panels as long as you fall within that window of wattage and voltage, the guide on our website. And then we'll tackle one more question. Thanks for your comments and questions coming in there. We'll just tackle one more question for today. This one's from Chris. Chris is saying, can you run through the switching on and off sequences for your inverters? That's a great question. The Microcare inverter, of course, has a big transformer in it. So there are big caps that have to be preheated or pre-charged to be able to switch on. So let's just run through quickly the sequence there. Let's start with off. Let's just say your system is running. How do I switch everything off? All right. So firstly, it's important that if you're connected to solar panels that you always close the tap. Take your foot off the accelerator pedal if you like. You've got to stop the flow in of power. Too often people don't understand the electricity that's flowing, and they often then will switch off the inverter, but there's still power coming from the panel. So number one, always, if you've got panels, you need to switch them off. And you can do that on your MPPT, the panel breaker. If you've got a Giza controller, it's the same story. If you've got a solar pump controller, whatever application, you've got to switch off the flow in of power. Close the tap, if you like, or take your foot off the accelerator pedal, as Voter likes to say. Secondly, then you switch off all the AC. So first, close the tap, no more power coming from the panels. And second, all the AC connections, switch it off. So that there's no AC power coming in that direction, no power coming from the panels. Then third, you're going to switch off the inverter. So if you've got a microcare inverter, there's on the screen, you push the two buttons, the middle button, the right button, and you just simply hold them together and it will switch off the inverter. And that will actually uncalibrate. It'll actually slowly switch off the system and make sure that there's no output also going onto this inverter. And once that's all happens and this inverter is now saying inverter off, then you can of course switch the breaker. Please make sure there's no load on there, no AC, no panels coming through. And then the last step is if you've got a fuse between the batteries and the inverter, recommended a DC disconnect switch, a fuse that you open that. Please, it's always important that if you do have some kind of switch that you pull the positive first. Okay, so that's switching off. I'll just run through again. Panels off first, all the power coming through, whether it's a pump controller, geyser, inverter, solar. Then the AC, if you've got any AC connection, make sure that goes off next. Then we're going to switch off the device, the inverter, the on-off. Actually hold your two fingers onto the screen and then make sure that there's no output going in the inverter. Then you're going to pull the breaker and then pull your fuse. And let's just do the opposite sequence now. I'm not going to switch this system on. I'm going to go in the opposite direction. Number one, I'm going to close the fuse between the batteries and the inverter. So make sure that there's a connection between the two of them. Then secondly, before I go and pull the breaker up on the inverter, I want to pre-charge the inverter. Microcare inverter has got a big transformer and it's got caps in it. There's two reasons why we want to pre-charge a microcare inverter. One is that if we don't, there's going to be, as we pull the breaker, there's going to be a little bit of arcing on that breaker, on the contacts. And over time, that's going to wear it down. So that's one reason. But the second is those caps are thirsty. They're going to need a lot of power as we start up this inverter. So it's quite important that we hold that pre-charge button. And I like to say people keep that pre-charge button in all the time. The screen will come up and it will say calibrating, but keep it in. Just keep allowing those caps to pre-charge. They demand a large amount of amperage, so it's quite important that they are pre-charged. And then once it's all done, you'll see that it will say inverter is off. And on that point, you can then lift the breaker. The inverter will start up and continue its sequence. At this stage, I haven't touched the screen yet to actually switch the inverter on. I've just got the whole motion, the powerful transformer, the caps warmed up, charged up, and we're ready to go. Then I'm going to, of course, start the inverter, hold the two on buttons, start the inverter up, and you'll see the calibration continue, and the inverter will get going. After that, I'm going to switch on the AC. The final step, then I can allow the panels to come through. Just please, if you've got an MPPT, make sure it's always panel breaker on first, so that the tank is open, the batteries are ready to go before you pull the panel breaker. All right, so there's a quick little sequence. Now, we were aware of some of these questions, so we've made some really cool videos. So please get in contact with our sales team, sales@microcare.co.za. What I've just described now, there's little videos on these things. And there's lots of other videos on the geyser controller. We've got about 6 or 7 videos on our awesome geyser controller for you to go and have a look at. All right, so there we go. Johan, your question on upgrades, absolutely. Any microcare product can be upgraded to the latest level. Craig asking about geyser controllers. So how many panels? We've touched on that. You can go find some more videos on our geyser controllers. And Chris asking about the switching on and off sequence. We've got lots of videos on those as well. I've run through the basic sequence. It's very important that we understand what's actually happening with the power is flowing. Right, I hope those are helpful. Keep your questions to answer and look out for some guests rather to be joining us here every Tuesday at 2 o'clock. Don't forget to like, share and subscribe for our YouTube channel. And hope to see you soon. Keep enjoying the beauty of solar here down in PE. Lots of sunshine at the moment and a wonderful time of the year for solar. So God bless. Thanks for watching.